Okay, so this is just more practice of what we did yesterday, okay? When we're talking about linear inequalities, remember we first have to convert it to slope-intercept form. If it's in standard form, then we start by graphing at the y-intercept and then using the slope to find our additional points. Just remember, if it's y is less than or greater than, then we're going to use a dashed line. If y is less than or equal to or greater than or equal to, we're going to use a solid line. If y is less than or equal to, we're going to shade below. If y is greater than or equal to, we're going to shade above. So number one is already in slope-intercept form. So we are just going to start by graphing at our y-intercept, which is -2. Okay. My slope is -2, but we have to make it a fraction for rise over run, so we simply put a 1 under. We're going to go down to right 1. Down to right 1. Opposite direction would be up to left 1, up to left 1, up to left 1, up to left 1. Since it's greater than, we are going to do a dashed line, which means just skip a few spots, not connected completely. And since it's y is greater than would be above, and above this line would be over here in this region. Okay. Number 2 is in standard form, so first we have to convert it to slope-intercept form. So first we are going to subtract 6x. Negative y is greater than or equal to -6x minus 16. Divide by -8. Since I divided by a negative, remember we're going to flip this from greater than or equal to less than or equal to. -6 over -8 simplifies to 3/4 x. And then -6 over -8 simplifies to +2. 2 is the y-intercept is where I start, so I go above 2. My slope is 3/4, which means we are going to go up 3, right 4, up 3, right 4. And since I can't go any further, I'm going to go the opposite and go down 3, left 4. Okay. Since this is less than or equal to, we are going to do a solid line. And less than or equal to means below, so we're going to shade under. Okay. Number 3. Again, it's in standard form, so we're going to convert it by subtracting x. Then I'm going to divide by -1. So y, since I divided by -1, it flips it from less than or equal to greater than or equal to. -x over -1 is just positive x. My y-intercept is 0, so we're going to start at the origin. And since my slope is 1, 1 over 1 is up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1. Opposite direction will be down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1, down 1, left 1. Since it is greater than or equal to, it's a solid line. Since it's greater than or equal to, we're also going to shade above. Okay. This one's a special case, so it's already in y-intercept form, slope-intercept form, but since it's just y and a number, this means we're going to cross the y-axis at -1. So -1 on the y-axis is right here. It has to be a horizontal line in order for it to cross the y-axis, and since it's greater than, we're going to do a dashed line. And since it's greater than, we're going to shade above. Okay, so that's just a little review of what we've already talked about. But then we have to figure out what solutions are possible. Okay, so these are already in slope-intercept form. So we're going to start by graphing at +4 on the y-axis. -2 is down 2, right 1, 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 or up 2, left 1. It's a dashed line because it's greater than, so just skip a few sections. Since it's greater than, it's above, and above would be this area. And now we're going to check for solutions. What this means is we're looking to see which one of these coordinates, and there could be more than one, is in this shaded region. Not on the line because it's dashed. We're looking for just the shaded region. So point A is -5, -2. That's not in the shaded region. Point B is 3, 0, which is in this shaded region. Point C is 2, -1, which barely misses, so it's not C. -4, -6 is not in the shaded region. -3, 7, It's hard to tell. 1, 2, 3, 4, 5. It looks like it could possibly be, but it looks like it could also be on the line, so we're not going to include it. 2, 0 is on the line, but since the line is dashed, it's not a solution. 5, 2 is in the region, so G. Negative 1, 3 is not, so it's not in a solution. Negative 3, negative 1 is not in the region. Negative 2, 5 is close, but not in the region. 6, 0 is, so that's K. And negative 1, 6 will be also, so that would be L. Okay. The second one, we're going to start at a y-intercept of negative 1. My slope is 1/2, so that means I'm going to go up 1, right 2, up 1, right 2, up 1, right 2, or down 1, left 2, down 1, left 2, down 1, left 2. Since it's less than or equal to, it's a solid line. And since it's less than or equal to, we're going to shade below. Okay. Now we're going to check which points are in the region or on the line because it is a solid line. So negative 5, negative 2 is not. 3, 0 is, so B is a solution. 2, negative 1 is, so C is a solution. Negative 4, negative 6 is in the region, so D is a solution. Negative 3, 7 is not. 2, 0 is because it's on the line, and since the line is solid, that means that you can include it. So F. 5, 2 barely misses it, okay, because so we have to be accurate with our graphing. Negative 1, 3 is not. Negative 3, negative 1 is not. Negative 2, 5 is not. 6, 0 is. And negative 1, 6 is not. Okay, so those are my 5 solutions. Last one, we're going to start at the y-intercept of negative 3. Negative 2 over 3 means down to right 3. So I'm going to go down to right 3. Can't do it anymore, so I'm going to go up to left 3. Up to left 3. Then since it's less than, it's just a dashed line. And then since it's less than, we're going to shade below. So again, we're just going to check which ones are in the shaded region but are not on the line because it's a dashed line. So negative 5, negative 2 is a solution, so A. 3, 0 is not. 2, negative 1 is not. Negative 4, negative 6 is. Negative 3, 7 is not. 2, 0 is not. 5, 2 is not. Negative 1, 3 is not. Negative 3, negative 1, that's a really tight one, is on the line, but we do not include on the line because it's a dashed line. Negative 2, 5 is not. 6, 0 is not. And negative 1, 6 is not. So this one only has 2 solutions.